Hello, welcome to our project on nuclear chemistry. Today, we will be giving you a general overview of what this is about, as well as explaining the history and science leading to atomic bombs, such as the one dropped in Hiroshima in 1945. Bullseye.
There are two different types of atomic energy that can be formed. The first is nuclear fission, and the second is nuclear fusion. In nuclear fission, the isotopes that are most normally used are uranium-233, uranium-235, and plutonium-239. This is because these isotopes are already generally unstable, so they're easier to break apart. More specifically, nuclear fission is when the nucleus of an atom is hit by a neutron from another atom. This causes it to split apart, and a chain reaction ensues. You dummy. Here we go. Bullseye.
Hi, I'm here to talk to you about fusion. Fusion happens when two smaller atoms that don't want to be fused together are fused together. This creates a large amount of energy, such as used in the H-bomb. Think about pushing a cart down a hill, but at the top of the hill, the cart is already stuck in a hole, so it really doesn't want to go down the hill. So this is done using hydrogen isotopes, such as deuterium or tritium, and fusing them together to create helium. Fun fact, this is how the sun also produces its energy. And let's go watch an example. Bullseye.
Let's talk a little bit about the Manhattan Project. In October 1939, famed physicist Albert Einstein sent a warning to current U.S. President Franklin Delano Roosevelt. He was warning him that Nazi Germany was already developing a nuclear bomb, and the U.S. needed to get started on that or they would fall behind. In August 1942, Roosevelt began the Manhattan Project so as not to fall behind the Germans. In 1944, 6,000 scientists and engineers were already working on the project, led by Robert Oppenheimer, a famed physicist. They worked in the Los Alamos, New Mexico, in the middle of a desert, because it was very secluded and people weren't around to be suspicious of what was going on. Major General Leslie Groves oversaw the project for the U.S. military, but many private corporations, such as DuPont, helped in the creation and transportation of the nuclear materials. At its peak, 130,000 Americans were employed in this project, and 37 facilities were being used. On July 16, 1945, the first atomic bomb was exploded at Alamogordo, New Mexico. Nothing like this had ever taken place before. It was a turning point in the war, although it was not known at the time.
The effects of the atomic bomb were first demonstrated on civilian targets in World War II. In 1945, the U.S. government was planning a full-scale invasion of Japan. However, when they estimated the costs were too high. So, President Truman was informed of the Manhattan Project, and he authorized the bombing of Hiroshima, a Japanese city that was densely populated. On Monday, August 6, 1945, at 8:15 a.m., the plane Enola Gay dropped the atomic bomb, codenamed Little Boy, on Hiroshima. 70,000 were killed in the blast. However, after a year, the casualties were estimated to be 166,000 due to radiation poisoning. The entire city was reduced to ground zero, with 70% of buildings being completely obliterated and 7% simply shreds. The effects were so great that the U.S. government actually censored the press of Japan so that the public would not know about the bomb. This was the first time that the atomic bomb had been tested on civilian targets.
The second atomic bomb was dropped on Nagasaki, Japan. After the first bomb in Hiroshima did not have the desired effect of an immediate Japanese surrender, President Truman authorized the dropping of a second atomic bomb. This bomb was codenamed Fat Man, and the mission was entrusted to the men of Bockscar, an airplane commanded by someone named Bach. On August 9th, 1945, at 11:02 a.m., the bomb was dropped. It had a force of 22,000 tons of TNT. The hills surrounding the city channeled the force of the explosion towards the center, and as a result, people in outlying villages did not suffer the effects. 60,000 to 80,000 people were killed in the blast. 40,000 were killed immediately, and the rest suffered radiation poisoning after the fact. Fun fact, the bomb was supposed to be dropped on Kokura, Japan, but the cloud cover was such that they wouldn't be able to see the effects, so they moved it to Nagasaki.
While we talked about the atomic bomb using fission as its source of energy, the H-bomb, which was developed a little bit later, is basically a tweaked version. However, it's much stronger than the original bomb dropped at Hiroshima. The magnitude of its demonstrated explosion is actually 450 times that of the Hiroshima bomb. The reason why it's so greatly overpowering is that it's a combination of fusion and fission reactions inside a core. So an initial fission reaction starts it off, and this sets off a fusion, which then sets off another fission, and when those all are done, it creates a very high temperature of about 1 million Kelvin, and when that is heated, when that heats the container up enough, it hits a tritium boost gas, which is tritium is a heavy H isotope, and once that is hit, it ignites too, and so then it hits a spark plug, which compresses, and then it hits a fuel cell. When this fuel cell detonates, boom. And now we use lithium-6 because we proved through science that it's much more effective and it's a lot more unstable and it makes a bigger explosion. But back then, say the Cold War, they would actually use more of the plutonium and uranium isotopes in order to create a fuel cell. And so once that core detonates the tritium gas and then hits the spark plug, that's when you get that fuel cell detonating and you get your ground zero. Woo! Brendan.
Oh, you want to do this now? I'm going to be talking to you a little bit about the neutron bomb. The neutron bomb is a more modern bomb that we've developed. In 1958, Edward Teller began work on this project in the Lawrence Radiation Lab. In 1963, also at the Lawrence Radiation Lab, the first neutron bomb was detonated. It is believed, we don't really know. In 1974, the neutron bomb was officially added to the United States arsenal, and the architect of that bomb was Samuel Cohen. The neutron bomb is similar to the H-bomb, but it releases a lot more radiation. This is because the neutron bomb doesn't have the outer shell of uranium that the hydrogen bomb has, and as a result, it releases a lot of neutrons out into its surroundings. This causes less of a physical explosion, so material buildings will be left intact while more people are killed by the radiation. One specific example of how this could be useful is that if there is a large group of enemy tanks attacking, you could detonate a neutron bomb in the middle of them. This would take out most of the enemy soldiers while leaving their tanks relatively intact, so that the United States forces could then use those tanks.
Hi. We all know the short-term effects of the atomic bomb. Burns, your organs compressing until they finally explode and you splatter all over buildings. Buildings collapsing, ground zero, yeah, we all know that. However, that's only 95% of the emissions from an atomic bomb. The other 5% is radiation. Atomic bombs can emit alpha rays, gamma rays, neutrons, and electrons. Gamma rays are so destructive and they also travel at the speed of light. Neutrons, also wherever they touch, make that area radioactive. And over time, as the blast radius increases, the effects are less dangerous. However, they're still pretty bad. Symptoms of being hit by an atomic bomb, if you're not dead by the blast, include diarrhea, vomiting, nausea, hair loss, and skin bleeding, like just immediately, and it's pretty random, but it's pretty bad. Here we have someone who, although was not at Hiroshima, knows some stuff about atomic bombs.
Yeah, so my dad knows a guy whose friend's girlfriend is related to my cousin, whose dog's Walker is also related to my friend, who had a dad who was in a nuclear bomb when they hit Hiroshima, you know? It was he told me there was phases to it. It was like scorching and burning, and also just it's horrible to see. You know, it's just like it's screwed up. You know.
Thank you, Patrick.